Hello, and thank you for joining me today as we practice calculating acceleration. So for our first practice problem, a flower pot falls off a second-story windowsill. The flower pot starts from rest and hits the sidewalk 1.5 seconds later with a velocity of 14.7 meters per second. Find the average acceleration of the flower pot. So for this, I want to make sure that I underline the things that I know. I'm going to draw a picture. So I have a flower pot on a windowsill. Here's my flower pot. It's going to fall and land on the ground, shatter into a whole bunch of pieces. So we get a bunch of broken little pieces here. And this took 1.5 seconds, so my t is going to be 1.5 seconds. I know that the v, right before it hit the ground, was 14.7 meters per second. And so here I can make a list. I know I have a final velocity, so if we think back to my acceleration equation, a equals vf minus vi, all divided by t. So these are my variables. I have vf, I have vi, I have a, and I have t. So then we fill in what we know. So start. Flower pot falls off a second-story windowsill. It starts from rest. So starting from rest, I know that my VI is going to be 0 meters per second. Hits the sidewalk 1.5 seconds later. So my T is going to be 1.5 seconds with a velocity of 14.7 meters per second. So that's because that's right before it hit the ground. I know there's 14.7. Find the average acceleration of the flower pot. So I'm looking to solve for A here. So I have A equals VF minus VI, all divided by T. Because it's solved for A, I can then plug numbers in. A equals 14.7 meters per second minus 0 meters per second, all divided by 1.5 seconds. And if I take 14.7 minus 0 divided by 1.5, I'm going to get an answer of is going to equal 9.8 meters per second squared. If you think back to last unit, 9.8 is the number we worked with. That's going to be your acceleration due to gravity. So that's how we can calculate all of this, and we can figure out gravity is 9.8 meters per second squared. All right, I'm going to do one more with you, because what if we don't solve for acceleration? What if we solve for a variable? So let's practice one of those. Number one, I'll do number one. We will calculate the final speed. So a car accelerates from a stop at a rate of 2 meters per second squared for 20 seconds. Then continues at a constant speed for 40 seconds. Graph the speed versus time of the car. What's the car's speed at 10 seconds? And what's its final speed? So I want to know what is the car's speed at 10 seconds. Okay, so this is what we're going to calculate. And we'll do the rest of this problem when we talk about graphing tomorrow when we talk about graphing. So things that I know. One, my equation is A equals VF minus VI, all divided by T. And things that I know. VF, VI, A, and T. So looking back at my question, first thing I underlined was accelerates from a stop. So if I'm stopped, my VI is going to be 0 meters per second. It accelerates at a rate of 2 meters per second squared. So A is going to be 2 meters per second squared. And then it accelerated for 20 seconds, but if I look down here, I want to know what is the car's speed at 10 seconds. So if I only do this for 10 seconds, what is my final velocity going to be? So if we take this equation, A equals VF minus VI, and we solve it for VF, we can move some variables around. So let's start here. Okay, so the first thing I need to do when I have this equation to get VF by itself is I have to get rid of this stuff on the bottom. So because t is on bottom, I'm going to multiply this side by t. I'm going to multiply this side by t. So these are going to cancel out. I'm going to be left with a times t equals vf minus vi. And then because these are connected by subtraction, I can add vi to both sides. So I get, so minus vi plus vi, those are going to cancel out. So I'm going to get vf equals vi plus a times t. And now that I have my variables all lined up, I can plug numbers in. So vf equals, we said vi was 0 meters per second, plus my acceleration was 2 meters per second squared, times my time was 10 seconds. So I can take 0 plus 2 times 10, and we know 2 times 10 is 20, so 20 plus 0, my VF is going to be 20 meters per second. So that's going to be my situation. Ideally, we draw a diagram before we do this. So I know that I'm starting at 0. I know that I go, and my car is going to have a final velocity here that we're not sure of, but we know this is, we don't need a distance, we need a time, sorry. We know that this took place over a course of 10 seconds. And then we can calculate, and we still come out to 20 meters per second here. I have a couple practice questions for you, so I'm going to let you work through these on your own. If you pause the video now, you can work through them, and you can check your answers with what I write up here. So number 1 should be 1.6 meters per second squared. The second one is 0.075 meters per second squared towards shore, because they gave us a direction on this one. Number 3 is 3 meters per second squared, and because it's going northbound, it's going to be to the south. Number 4 is 0.85 seconds. So looking for how long it would take. And the last one, so I want to know is going to be 11 meters per second, because we're looking for speed. So 11 meters per second, we're going to the west, so west. Those are your answers. Thank you for working through these, and I will talk to you tomorrow.